We're going to start off today with our bell work on page 196 in your books. So I want you to go ahead and open up your books, or you can pull out a scratch piece of paper. I want you to do these two problems. On number 1, I want you to describe the transformation from the square root parent function. So describe what A, B, H, and K are doing. On number 2, I want you to solve both of those equations for x. And I want you to leave your answers as simplified radicals. Go ahead and pause the video now, work through those two problems, and then unpause the video to check your work. All right, let's go through these. On part A, our H value is right here. Don't forget H is the opposite. H is 4. Our K value is over here. A is right here. That's just a 1. And our B value is right next to the X. That is also a 1. So the only things affecting our transformation are H and K. This one is going to go right 4 and up 2. Part B, we have our A value right here. B value right next to the X is just a 1. Here we have the opposite, and so my H is -1, and K is -4. So this is going to vertically compress by 1/4. And then it will also go left 1 and down 4. All right, part C. A is 1, B is -1, H is 0, and K is 5. So our B value is going to make it reflect over the y-axis. Don't forget, you do need to explain that it's over the y-axis and not the x. And then it's going to go up by 5. All right, last one on number 1. We have our A right here, our B value of 1, H is 0 again, and K is 5. So this is almost exactly like part C, except it's A that's -1 instead of the B value. When A is negative, it's going to reflect over the x-axis, and then it goes up by 5. All right, number 2. To solve number 2, I'm going to begin by adding 23 to both sides. That's going to give me 4x squared is equal to 48. I'm going to divide both sides by 4. I get that x squared is equal to 12. To get rid of the squared, we're going to take a square root of both sides. When we take a square root of both sides, we get 2 answers. We get both the positive and the negative. So I get that x is equal to plus or minus the square root of 12. I need to break down the square root of 12 because it said to leave it as a simplified radical. So things that go into 12. When I break down the square root of 12 all the way, I get the square root of 3 times 2 times 2. And so this is going to simplify to be x is equal to positive or negative 2 square root of 3. All right, same exact process on part B. So first I would subtract 18 from both sides. That would give me 7x squared equals 21. Then I divide both sides by 7. I get that x squared is equal to 3. Square root both sides. That's going to make my radical cancel out. I should have done that over here as well. There we go. And don't forget, when we do a square root, we get both the positive and the negative result. And I get that x is equal to plus or minus the square root of 3. 3 is prime, so I don't have to worry about breaking that down at all. All right, I want you to flip forward in your books to page 238. Page 238. The area of a backyard is represented by the formula A equals 1/2 s squared. That shouldn't be a minus. That should be an equal sign there. A equals 1/2 s squared. Find the length of the side. So the length of the side, this is telling me to find S. Find the length of the side if the area of the backyard is 49 meters squared. So I'm going to take 49 and I'm going to put it in the place of the A right here. So this is going to become 49 equals 1/2 S squared. All right, so we are solving here. That means order of operations backwards. Anytime we are solving or isolating, we go backwards. So when I look over where S is, there is no addition or subtraction, so I don't have to worry about that step. However, I do see division. That's what's going on with this 1/2. To undo division, I need to use multiplication, and I'm going to multiply by whatever's being divided on the bottom. So I'm going to multiply both sides by 2. That's going to make my 1/2 cancel out over there. 2 times 49, that would be 98 equals S squared. Then I want to do the square root of both sides. That's going to make my S squared cancel out. I'm going to get positive or negative square root of 98 equals S. And then I need to break down the square root of 98 to see if that simplifies it all. So let's go ahead and break down the square root of 98. Go ahead and pause the video, break that down, and then we'll check our work together. All right, so we got 98 by multiplying 2 and 49, so I can start off by breaking it down to 2 and 49, and then 49 is 7 times 7. So I have a pair of 7s, so I get plus or minus 7 square root of 2 is equal to S. But S is the side of somebody's backyard, and lengths can't be negative. So my only real answer here, my only true answer, is 7 square root of 2. All right, so S is equal to 7 square root of 2 meters. Or if I pop that into my calculator and I get that as a decimal, that's about 9.899 meters. So almost 10 meters there. All right, flip over to page 239. Page 239. Question number 4 up at the top of the page. Susie traveled 4 miles east to the store. Then she traveled 7 miles north to the bank. Find the shortest distance Susie needs to travel in order to return home. Okay, so to figure this out, I'm going to use this graph to help me a little bit because I've got left, right, up, and down, so I can kind of use this as like north, south, east, and west. So that's what I'm pretending here. And I'm going to put Susie's home right here at 0, 0. All right, so it says that Susie traveled 4 miles east to the store. So I'm going to take that over to the 4 on the x-axis. That's going to represent 4 miles there. And then she traveled 7 miles north to the bank. All right, so I have labeled the store and the bank. 4 miles east, 7 miles north. Find the shortest distance that Susie needs to travel in order to return home. Well, the shortest distance between any 2 points is a straight line. So from the bank straight to home, this is the distance that we want to find. Right here. What is this? Notice it made a triangle on my graph over there. So I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared, to figure this out. This thing that we're looking for, that question mark over there, that is c. That is the hypotenuse of our right triangle. This is a right triangle right here. The longest side, the side directly across from our right angle, that is the hypotenuse. A and B are the 2 legs of this triangle, so that would be the 4 miles and the 7 miles. it does not matter which one you call A and which one you call B. So I'm going to substitute in. So we have 4 squared plus 7 squared is equal to C squared. Well, 4 squared is 16. 7 squared is 49 equals C squared. I'm going to add the 16 and the 49 together. When I do that, I get 65. So 65 is equal to C squared. I don't want C squared. I want just C. So I'm going to do the square root of both sides. Squared and square root cancel each other out. So I need to do the square root of 65 to figure out how many miles it's going to take her to be the shortest distance to return home. So I pop square root of 65 into my calculator, and I get that C is approximately 8.062 miles. For part B on this question, it says, what is the total distance Susie traveled all together? So she goes from home to the bank, to the store, and then back to home. So from home to the bank, that was 4 miles. From the bank to the store was an additional 7 miles. And then from the store straight home, that's what we just found up above. That was 8.062 miles. And so I'm going to add all of those up. And when I add those all up, I get 19.062 miles. All right, go down to the bottom of this page, bottom of page 239. We've got one more problem that we're going to do together. On the bottom of page page 239, it says the height of an ant can be represented by the equation h is equal to the square root of a divided by 2 plus 1, where a is the age in years of the ant, and h, I'll underline that, h is the height in millimeters. Now, first of all, I don't think ants live for years and years and years, but let's roll with this story problem because it shows us some important ideas that you guys are going to be using on your homework. So, how tall is our first question? If I want to know how tall, am I looking for A or am I looking for H? We're going to solve for H, for the height. How tall is the ant in 36 years? So we're going to take 36. We are going to sub this in for A. So I'm going to recopy that original equation. We have h equals the square root. Instead of putting the letter A there, we're going to put a 36 there. Divided by 2 plus 1. So now I am solving for h, but notice h is all by itself over here already. So I'm going to use order of operations, but I'm going from the top down. This is already solved for h, so I just need to stick things in my calculator. So up in that numerator, square root of 36. I know the square root of 36. The square root of 36 is 6. So I've got 6 up in my numerator there. 6 divided by 2 plus 1. Well, 6 divided by 2 is 3. So I have h equals 3 plus 1. 3 plus 1 is 4. So the height is 4 millimeters. And the last part of this question, down at the bottom, it says, if the height is 7 millimeters. So I'm going to take 7 and we are going to sub this in for h. Then we want to figure out how old is the ant. So find A. We want to find the age of the ant. So I'm going to take the 7. I'm going to put it in the place of the h this time. So I have 7 equals, and then up in my numerator, square root of A over 2 plus 1. All right, now this time A is not all by itself. So I am using order of operations, but I can't just take it and pop it into my calculator. I'm going to need to get the A all alone, which means undoing the operations that I'm seeing right here. So any addition or subtraction on this side over here where A is, I'm going to need to subtract 1 from both sides. 7 minus 1, that's 6. 6 is equal to the square root of A over 2. All right, so we did our addition and subtraction. There is no other addition or subtraction over there on the side where A is. So now I'm moving here to multiplication and division. When I look over here, I see a fraction bar with a 2 on the bottom. That means division. Fractions mean division. And what operation undoes division? Multiplication. I'm going to multiply both sides by 2. It's going to make my 2's cancel out there. I'm going to bring my work up and around here. 2 times 6 is 12, so I have 12 is equal to the square root of A. So I got done with my multiplication and division step. So now I'm here at the exponents step, and while I don't see any exponents, I do see a radical. I see a root. When do we use roots? We've been using roots to undo exponents, so I can use exponents to undo a root. What kind of root is this? What's the index on that root? Index is a 2 here. So since the index is a 2, it's a square root, I am going to square it to make it cancel out. And according to my rules of algebra, if you do it to one side, you've got to do the exact same thing to the other side. So I have to square this side also. So squaring and square rooting cancel each other out. I have just the A all by itself over there on the right. On the left, I have 12 squared. That means 12 times 12. Pop that into my calculator. And 12 times 12 gives me 144. So I have A equals 144, and we are measuring A in years. I find this a little bit unbelievable that an ant lives to be 144 years old. But I've also never seen a 7 millimeter tall ant. For all I know, they do live for a really, really long time. All right, guys, go and take care of homework number 5. That is due tomorrow morning. I will see you guys later. Have a great rest of your day.